Back. Good morning, everyone. Good morning once again. Yes, this is Dennis Muyomba, or you can call me Dennis Favor. Yes, we are going to start today. We are going to see data analysis with Numpy in Python. Yeah. The presenter of today, I'll pass it down there, is Dennis Muyomba. On my X handle, you can call me Dennis Favor. My email is down there, dennisfavor2001 at gmail.com. Yeah. So without any wastage of time, let us dive into what we are going to see today. This is our outline for today. We are going to see an introduction to Numpy, installing and importing Numpy. Then the last shall be Numpy array broadcasting. I have not touched those in the middle. We are going to touch them, though I have not mentioned it here. So let us go straight away to introduction to Numpy. First of all, we need to understand what is Numpy. Why do we need to study Numpy? Where can we basically apply the knowledge of Numpy library or as a package when someone is designing a model or when someone is coming up with a project? So all of such questions are going to be answered here as we go through our presentation of today. Firstly, Numpy is a numeric Python. As you hear Numpy, Numpy is just a abbreviation of a full called numeric Python, where we deal more in numeric computing. When I say numeric computing, yeah, actually deal more in mathematics. And our mathematics here is simple. It is not of integration and differentiation. Here we are going to delve more in dealing with arrays, the mathematical operations which can be performed on arrays. I believe all of us right now, we know what we mean by arrays. Yes, that is a memory allocation that can store a new diverse or big amount of data. All right, let us go. So here I've brought out the reasons why we use Numpy. Because someone may be asking himself or herself a question, but what is the difference between Python lists and arrays? Then why do we need to study arrays again when we come to Numpy? I'm going to answer you shortly. So firstly, why we use Numpy instead of Python lists? Here we see that it deals more in performance. When we speak of performance, that the speed, the speed that Python lists and Numpy arrays that really take to finish a task, they really differ. Here we see in the concept that when you have a big amount of data that need to be analyzed, you cannot use it because there you actually waste time. You will not be able to complete a bigger task in a short period of time. Then a second point here is memory efficiency. How we can explain memory efficiency is in a way that when you have a complex big data sets where you can easily divide that data set into small portions and handle every portion differently from other portion. So doing so, you actually be in position of allocating memory to different portion of data sets, and in there you utilize memory efficiently. Then the last point is ease of use. Ease of use. When you have when you want to perform a complex mathematical operation on a particular data, you cannot use lists. Do you know why? Because when you use lists, you actually have to use loops. You actually have to integrate in other components for you to be able to use it, which is not the case when you come to Numpy arrays, because Numpy arrays, it provides you with 2 dimension and 3rd dimension, as we are going to see it through our slides today. All right. Let us continue. Then here, yes, here. We are here. So I never read it and heading for this one, but the heading of it was giving you some of the scenarios or some of the areas, some of the ideas where we can use NumPy arrays. And our first point here is in data analysis and data science. Those of you outside there who really would like to engage in data analysis and data science as our major common theme, computer scientist and IT, then you really have to know NumPy. Because in data analysis and data science, we deal with data, analyzing the complex data sets of companies altogether. So there is no way how you'll be able to analyze the data sets of different companies. An example of e-commerce company like Jumia, like Clove and other companies, when you do not know Numpy altogether. Because in there you have to do what you call data cleaning, transformation, and aggregations. Hope we are clear. Then the next point is 3D modeling and game development. In 3D modeling, we have some components called transformation. And in transformation here, we look at position, we look at 3D scaling, we look at rotation, where we try to manipulate an object, but not changing its shape or size or position in that way. So it helps you when you're developing a game. When you're developing a game, you need to know the characters, the behaviors of different characters in your game altogether. Then the last one is signal processing. When we speak of signal processing here, we mean in the way that you want to remove every unnecessary noise from your audio. Like I have said here, an explanation that in an audio processing project where you need to filter noise from a signal, NumPy provides you the functions necessary to implement Fourier transforms and analyze frequency components. Yes. All right. After understanding that, I think we need to go now to hands-on. We need to do some codes here. We need to program here. So, firstly, we are going to first install our NumPy. Hope all of us, we have Visual Studio, PyCharm, and whatsoever you are using. Then you install the necessary components that are required. Then we are going to install NumPy. You can press Command R, or you go to your search button and put in command prompt. Then you press OK after you putting in CMD. Then here you write pip to the pipeline, install NumPy. This is the simple code that you easily write, and then you install your NumPy. It will, when you press it, it will be able to download all the necessary packages that are required or that are found in NumPy. Me right now, even if I don't run it, because I already have it in my one on my device. All right. So after installing it, then you can go to your Visual Studio if it is the one you are using, and then you test and see whether it is there. Yes, here I was trying to work in with some. Here I was trying to deal with some. Uh, yes. Let me try. Let me first move this. Right here. So you can write import. Now we are going to import it. Import NumPy as MP. You see, then it does not brought any error, simply meaning that I already have it in the what? I already have it in the system. Then you may be asking yourself a question, why do we use NP? NP, actually, we are trying to simplify tasks here because, you know, in artificial intelligence and machine learning, our major task is that to simplify things for the society, which is very hard to find solutions for that, for the society. But even if you don't use an NP and import NumPy, you will also be correct. There is no problem in that one. But for me, I prefer providing an alias for it, yeah, so that we can work with it very well. Let me navigate back to our slides. Then when you are done installing and importing your NumPy, then our next key task here is we are going to now deal with NumPy array creation. As I've told you, as I told you recently that in NumPy, actually we are dealing with mathematical operations on arrays. If you are doing mathematical operation on arrays, meaning that in all of our course units, we are going to be dealing with arrays. Is that okay? Yes, as we are going to be seeing. So as I said here, that an array allows you to store the collection of multiple values in a single data structure, which may not be the same case with lists. For lists, you can only store data, one-dimension data. But when you come to NumPy array, you are actually able to store up to 3 dimensions, So here we are going to see how we deal with NumPy array. When you come back to our Visual Studio, I have already imported it. Then I can say, I can call it this one. and I say array equals to NP, because I'm using Numpy, so I have to refer to it. NP dot array into this one. You can name it any whatsoever you want. NP into one. Let me give it some values that it can help me to store. Oh, then 5. So I've given it some elements here which can help me to store. Then if I try to run this one, let me first move this one. If I run this one, it must give me an output of the array which I'm working with. There is 2 commas here. Let me remove one. Then we run again and we see. Run again and we see. Run again and we see. Just run again. All right. Oh, sorry, we didn't try to print. I meant see that first. So we try to print our array which we are dealing with. So when you print, then we run it. Then it has given us here an array as an output of 1, 2, 3, 4, and 5. Hope I'm not going very fast. Hope we are together. All right, all right, all right. So you know, in Uganda it is morning, yeah. So I don't know that side, but here I'm in Uganda and it is morning, our time. All right. So after that, then we are going to sing, because as I told you, we are dealing in arrays. So in arrays, you can perform different operations on arrays. And one of them here, which we are going to see in NP0s, where you give an input using the attribute called NP0s, and you want your output again to be zeros, then your question may be, why do I need to use it? Recently here, I think some 3 weeks or 1 month ago, I was working on a certain project, and the project which I was working in, actually, it required me to have this. Don't mind it was of 5 values in the way that I was using gestures, and everything on my hand, I had to denote it as a 0. Because remember, as a 0, when you denote it as a 0, you're actually disabling your gesture, that it should not perform anything. That's why I had to use it also. Let us also see its operation here. Let us see its operation here. I can come and I say, let me call it array2 is equal to np dot np0s. Then I specify the number of elements which I want. In my project recently, I was using 5 because it was the elements, it was the fingers 1, 2, 3, 4, and 5. Then I print it, array 2. Right. Let us run this one and see. If I commit this one. So, and let's remove it. Let us try to run this one and see the output. Now you see here, down here, in this which I've highlighted, it has given you 5 elements, but all of them of description 0, as you have seen there. Then after understanding that, there is also what we call Numpy arrange. Numpy arrange, for it, how it works, it helps you that you specify where you want to start and where you want to end. Take an example. You want to retrieve a data from a different data set, yeah? And because the data set is very complex in its nature, you want to specify data like, I want to collect a data or to analyze a data from this particular day to this particular day. Remember, company keeps on running and inserting in data into its database or into its data set. So for you dealing with that, you have to use Numpy arrange, where you really specify the particular kind of data which you want. Is that okay? All right, let us also go. Let us also go and see it. So it is, I can call this one array3 is equal to np dot arrange into, let me, so I'm going to start from 1. I stop to 8, but each way I skip like some 2. Is that okay? All right. Hope we discussed this in our recent Python series when we use start, stop, and slicing stuffs, yeah, when we use that. So here, if I print array 3, oh, if I print array 3, okay, let me first try to make some values here. You can try to comment them, yeah? Though I don't want to comment them. I want to do everything specific, say that you can be in position to see them. If I run this one, you see, that's given me an output, but in the output, it's actually skipping one, one. Actually, it has given me odd numbers here, 1, 3, 5, and 7. That's how I had specified it. Is that okay? So NumPy arrange here, you can actually use it as I've told you when you're working on a complex data set and you want to retrieve a certain portion of data from that complex data set, because you may be in need of analyzing that particular data set and you're requiring how you can easily do it. So in there, we use NumPy and NumPy arrange. When we navigate back to our slides here, there is also this NumPy random run, which helps you to create an array of random numbers. Those of you who have studied Java as a language, it has also the concept of random run, where you generate numbers randomly, like a random generator. Okay? It deals more with random figures, random numbers. Let us also try to see it here. Uh, for this array, was done, NumPy dot, sorry, random random dot random dot random into, let me say I want it to generate in 5 range, yeah, or let me say in 10 range figures. 10 range figures. If I run this one, oh sorry, we didn't print it. And I say print into that array. Hope my voice is clear. As you see here, it has generated numbers actually for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as we have told it. So for it, it generates numbers for you. Yes, that's all it deals with. We say that this function is used to create an array of random numbers. All right, all right, all right. Okay, let us go to the major concept of NumPy, because all along we have been discussing one-dimension arrays, and you know that one-dimension array can only be aligned. Then two-dimensional, then anything which is two-dimension, it has length and width. Then anything which is three-dimensional, it has length, width, and depth all together. So when we go deeper into NumPy n-dimension array creation, that is where actually we see different dimensions coming into arrays where we can perform different operations, but right now not on one-dimensional array, but on different what? Various dimensions. Like here, we are going to stop on 2-dimension and 3-dimension. So we are going to look at 2-dimension arrays and we shall look at 3-dimension arrays. That's it, what it means. Here in definition, I say that an n-dimension array refers to the number of dimensions in which the array is organized. NumPy is not restricted to one-dimension arrays. It can have arrays of multiple dimensions. Yes, we are going to see some examples here. So here we are. All of us, we know something which is two-dimension, as I've told you. It must have the length and it must have the width. Here we are going to create a two-dimension array. Then after creating it, we shall try to perform the same operations which have performed on one-dimension array, like zeros, NP zeros as a function. We shall perform NP arrange as a function and random dot rand as a function. However, I will only perform for you NP zeros as a function. Then because we have covered the NP arrange and NP random rand as a function in one dimension array, I believe you will be in position to do the same in the second dimension. What? In the second dimension array. Right, let us see here. Here we are going to create a two-dimensional array with 2 rows and 4 columns. Okay. Let us do that. Let me remove this one because we don't need them both. Okay, so I'm going to create my array that shall store values. Let me say array1 is equal to np dot array into. Here we are saying we are creating two-dimensional arrays, yeah? Of 2 rows and 2 columns. So these are the columns, I think 11. Then the rows, we say they are going to be 2. Let me see, 5, 6, 7, 8. So here we are. Then if I try to print it, say print. So 2-dimension arrays. That is array 1. Here we are. Here we are. Hope I'm clear. If I run it, it must give me an output. Oh, there is an error. There is an error. Let me first whether we have an error in np.array. np.array. Oh. Okay. Right, I'm seeing an error. Let me try to correct it. See? Let's include this brackets to enclose all the array as of 1. Okay. Let us run it again. All right, now you see, say the two-dimensional array is of this kind. Then three-dimensional array. So we have created a two-dimensional array having 2 rows and having 2 columns. Right. As I told you, you can still perform the same operations you using the same concept which we discovered in one-dimensional array. Here we say that we can as well create multi-dimensional arrays from scratch using functions such as np0 function, np function, and random run. Then here I gave you an example of creating the n-dimensional array using np0s. Remember, in our one-dimensional array, we don't specify one element like np0, fine. Because remember, a one-dimensional array is like a line, However, when you come to two-dimensional array, it has 2 components, and that is length and width. Meaning that when you're also specifying it np0s, and also specifying it, you must show the rows and the columns, which is your length and your what, and your width. So we want 2 rows and then 3 columns to generate it for you very well. Let us print it. So print into right. Okay, right. Let us run it. Okay. and P and A. Let us try to correct that error. That error. Oh, oh, since it's here, I didn't include those another bracket. Let's include it and then I remove this. I wrap up this one. I run again. Now you see, I've given me this one as the NP0 two-dimension what? Two-dimensional array. Because I told it I want it first what? First rows, there must be two rows and then three columns. As you see that the rows are two and then three columns, right? Then because of time, you have me to do NP arrange and NP random what? And NP random run. Okay. I actually what I'm covering here, I'm giving you the basics of NumPy, and down there, when I'm finishing the presentation, I'll leave you with some links where and some books where you can go and help you to dive you into NumPy what? NumPy library. All right, let us go to what is called NumPy array attributes. NumPy array attributes, this one, it gives you an information and the operation of an array. Remember, like, you are a human being. But as a human being, there are components of you. There are different attributes that makes you a human what? A human being. So likewise to an array, there are different attributes that makes it what? An array. And here down, those are the sum of the attributes which we are going to be seeing down here. NumPy attributes provide you the required information about an array, and one of it is when you want to know the dimension of an array, you want to know the size of an array, you want to know the shape of an array, you want to know the data type of an array, and other what? And other information which you may need there. So without any wastage of time, let us start with the n-dimensional array, which I called n-min here. As you see this one, which I have highlighted, I called it n-min. So that's what we are going to see at first. Let us, I think we can deal with some here, and we don't need to create other arrays. All right, is here. Then what I do, I will only come and say print into it is called array1 dot n the end mean means that the dimension of that particular what? Of that particular array. So I'm getting here the dimension. I'm getting here the dimension of this very array, which we created at first here. Hope I'm clear there. All right, let us get it from here. If I run this one, now you see these two here, it has told me it is a two-dimension what? Array. Let me try to make it clear here. Array is you see, this array is two what? Is two dimension. It's two dimension. That's all what you have to know about the n dimension. It helps you to know the dimension of an array. You can create a three dimension and do the same. You can create one dimension and do the same. Is that clear? Okay. Let us then go to the size of the attribute. Size of the attributes. Here, it helps you to know the total number of elements that are consistent, that exist actually in a particular array. We are going to also to use the same array. We are going to use the same array. I'm going to say print. I say here, this array has all right. Correct dot. It's called so here you see I'm on one array. But actually, I'm performing different operations on that particular array. Here, I got its what? Is a two-dimensional array. Then I'm trying to get its size. Yes, so that this array has 8 what? It has 8 elements. It has 8 elements. It has 8 elements. So the array is having 8 elements. Can we calculate them manually? 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 elements in that particular one. In that particular, this one can help you also to know. Now remember, when we are sorting data in a particular database or data set, you may need to know the whole amount of data, the sum of it. So you can use the array what? You can use the array size. You can work with that to help you there. All right. So let us go into the NP array shape. NP array shape. This one, it helps you to know the shape. What do we mean by shape? What we mean by shape, like when I told you it a two-dimension, it has length and width. When it's having length and width, meaning that when you are inserting in data, it must carry two components. That is of column and of row. So in case you want also to discover that, you can also do the same. You can just come here and say print into. We are dealing with the same array which you created at first. Shape. Shape. All right. Let us run it and we want to see that. I believe it is 2, 4. 2 and 4. All right. As you see here, meaning it is 2, 4, which means that it has 2 rows and it has 4 what? 4 columns. It has 2 rows and 4 columns. Yes, that is it. Yes, that is it. Then lastly here on NumPy attributes, we are going to see its data type. Because when you speak of data type, like we have a lady, we have a man. You see, so the data type of them is what? Differs. So here, you may also find yourself that the data which you are dealing with has different what? Data types. And your boss or the person you may be working on analyzing the data for a particular company may need to know such what? Such concept to know the data type of the particular data which my employee is working on with. Is that okay? So it is simple also for it. It is the type data, which means data type. Let me do it here for you. I'll say print into, we are dealing with array 1 dot data type. All right. Let us run it for it. It says it is in 64, 64 what? Of 64, which means that our data type which we are dealing with is of int, or it is of integer data type, but of 64 what? Of 64 bits. Of 64 bits. Right. As I told you here, I'm trying to give you some basics of NumPy array. Say that when you go in there, you will not what? You will not waste time. As I told you, I'll provide with you some links where you will be in position to study other stuffs. Okay, let us see here NumPy array indexing. We are going to study here NumPy array indexing. When you have an array starts at index 0. It does not start at index 1, however, it starts at index, meaning that your first element in an array, it is stored at position 0 in a memory. Is that okay? So now, as you see here, we have an array of how many elements? There are 5 elements, if I'm not mistaken. 1 here is stored at index 0, and 9 here is stored at index 4. Hope I'm clear. So 1 here is stored at position 0, and 9 is stored at position 4. We can see that here. We can see that here. And we are done performing operations on this one. You can pause because I'm going to upload this on YouTube. Yeah, you can pause. You'll be able to go back and pause and see how you can deal with that. All right, let us see here. Here we are dealing with a two-dimensional array. Assuming we want to get an element, want to get a particular element in which row. Want to get a particular element, let me say in this row, in that particular row. So we are going to say print into, want to get that element, that particular row. You can see other. All right, 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 all right. So our array is called array one. With array one into, let me say, the second column, the second row, second column. Yeah, the element which is stored there. That's fine and see. Right, run and see that will give us an output as required. There is an error. There is an error. There is an error. Let us first see where there is an error. We put it here. Can I put this one here? Then we try to run again and see. Yes, you're right. We are in IndabaX. We are in IndabaX. Yes. All of this we are in our Python series. All right. Hope you can see. Element, input array, and try to see. Looking for you to access an element and you see. When you cycle this one, an element, want to access an element, code array one, this element is the second row. You see the second row, second column, second one, the second column. If we print this one, if we print element, we print our element here. Let's give us some good output there and we'll see. So we've done everything. We've done everything. They still out of bounds for access zone. It says that uh, you give it one, you give it one, and you see. If I run this one, has given me. So we have accessed this element 7 using this component. That first row, second what? Second column. Yes, as you have seen there. You can actually do also that same. You can actually do also that same with the first dimensional. Let me do that one here very fast. Say into array into 1, 2, 3, 4, 5. So then I'll say No, equals to A3 at position 3. You can guess which element is going to be printed. When I say printing, someone can guess before I print it out. Someone guess before I print it out. Which element do you think that our output shall be? One, two. All right, all right, all right. Okay, the time is over. I'm running. It is 4. It is 4. You guessed it right. Okay. All right, let us see. Let us see here on our slide. What do we have next? Okay, okay. Let us go to array slicing. I think for this one, we had discussed it earlier, though we didn't go into it. We didn't go deeper into it. But for it, it helps you to extract a portion of an array from a complex array or from a particular array. You may have an array which consists of 10 elements, and you want to extract a portion of 3 elements from that particular array. So how you do it also matters. That's why we use what we call Numpy array slicing. Here we say that Numpy array slicing is the process of extracting a portion of an array with slicing. We can easily access elements in that particular array in either 1, 2, or more dimensions, as we are going to see. I provided an example here, which we are going to deal in. We say the slice array 1 from index 2 to index 6. How many elements do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 elements, 2 to 6. Okay. Let me remove these ones. Let me remove these ones. So I create an array here, a one-dimensional array, equal to np dot array. Here I'm just using array 1 because it is easier for me. But again, you can use your name. There is no problem. You can use your name. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have these elements here, and you want to extract a portion of them. You want to extract a portion of them. So here I will say the slice array 1 from index 2 to index what? To index 6. I can say element is equal to array 1. I'm slicing from index 1. Was it index 2 to index 6? All right. Numpy. Actually, Numpy is the easiest library for you to learn fastly. Numpy, Matplotlib, and Pandas. We have already uploaded a video of Pandas you can check out at our channel. This one, I think by the end of today, it will be there. All right, all right, all right, all right. Oh, sorry, we didn't print this one. Come and say print. And then let us run again and see. You see? We have extracted a portion of an array from a complex array, but of particular elements as if we have 3, 4, 5, and 6, because they are at the positions which we have specified here. All right, all right, all right, all right, all right, all right, all right. So I think we can also do this one. Slice array from index 0 to index 8 exclusive with a step size of 2. With a step size of 2. Right. I have another task here to handle. Let me do it once. We say print into array 1. It was from index 0. Let me see. It's from index 0 to index 8, but with a step size of 2. Index 0 to index size with a step size of what? Of 2. You can guess which element shall be printed. Someone can guess. Someone can guess. You can guess before I run this one. 1 second. It is done. You're late. This is the one which you wanted. The first one is of this one. Then 1357 is the one which we wanted. But from index 0, our element at index 0 is 1, and our element at index 8 is 7, but with a step size of 2, 7, or 8. All right, let us continue. Then here you can modify array elements using using slicing. This one is very simple as you're speaking. It is very simple as how someone can speak. Let us do it also here. We see. Let me say I call this again is equal to array. I'm going to change the elements from position. Let me say from position 7, which is 6, up to position 8, which is 9, and give it a common what? And give them a common figure. Let me see. They want us to modify elements in the index onwards. All right. Let us do this one. 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 Let us do this one also. I say from 3 and onwards. Okay. Said from index what? Said from index 6 and onwards. Change it its element. Let me say we give it 19. We give it 19. Then if we try to run this one, if we try to run it again and we see, I'm printing array what? I'm printing array 1. All right, as the output which I want. Let me see. Okay. If you run this one, it must change the elements. See that from element 6, it has changed all its values to 19 as a consistent value. Actually, when you're dealing with machine learning and artificial intelligence, it helps you in automation where you use little time than someone who's doing the same task manually. Now here we have changed the data, maybe for a particular company, but with only one line of code altogether. Don't need to write many codes. That is why Python is the easiest language for everyone to learn. I'm about to finish, don't worry. Then this one we are using a start and stop as we have discussed about. That one is very easy. Let us go to this one, the very most interesting one according for me. It is called Numpy array reshaping. Numpy array reshaping here, we're actually trying to change the shape of an array without changing its data. It's like when a woman is trying to beautify herself, but without changing her identity, that she is a what? She is a woman. So that's what we are trying to do here also. We are trying to reshape an array, maybe from one-dimensional array to two-dimensional array, but without changing its data. I repeat it, without changing its data. You may have many elements in a particular array, and then you want to group them in the other they make you and give you what you call a two-dimension what? A two-dimension array. That is what we are going to look at here. When you're specifying for two-dimensional array, meaning that you will be in a position for you to specify the row and the column. Though I'm running out of time, we can do this one also. As I say, I have something that's remaining here. We are going to use this same what? We are going to use this same, let me see. Right. We are going to use this same, our same array. No problem. I say nope is equal to array 1 dot reshape. I'm reshaping it, but in 2 rows. Did I say 2 rows and 3 columns? Let us try that one and see if it will work. I believe if there are 9 elements, they're supposed to work. Then I call no. Call it nope here. Let me remove this one. All right. Let us run this one and see the output. Oh, there is an error. There is an error somewhere. Cannot shape array of size 9 into shape, please. I need that one. That one I need. Let me reduce them to 6. Let me reduce that one to 6. And then we run it and see. Reduce them to 6. It must give you an output. You see? So we say that 2 rows and 3 columns. But at first here, it was actually a one-dimension array. But because of reshaping, we have redefined our array into 2-dimension array simply using a reshaping function. And we have specified that we want 2 rows and 3 columns. It has given you 2 rows and 3 columns, as you have seen there. You can You can actually do the same with the three dimension, or do the same with the three dimension array. Do the same with in reshaping. I actually what I've come to know is that in reshaping, you come from a lower dimension to a higher dimension. You come from one dimension going to two dimension or three dimension. Then when we come to this other concept called flattening, that is where we come from a higher dimension to a lower dimension. Like someone was beautiful, and because of wanting her to beautify herself, then she became more ugly altogether. So from a higher dimension to a lower what? To a lower dimension. That is what we are trying to use. Though also with the same concept of reshaping, but specifying a negative one, meaning that you are going down. Is that okay? All right, let us also do the same here. And we see whether that will work for us. We say nope is equal to array one that we shape. Oh. Is it right? Let me try see. Nope. All right, we're on track. Oh, seems I've made some error. So this one we call numpy. We call numpy, not the particular array. All right, into that we want to flatten this particular array, but by going into its lower dimension. I don't create, let me first create a two-dimensional array here. Let me first create a two-dimensional array here. Sorry for that, empty, that array, hop, okay, comma, so I can remove these ones. These ones I don't need it. We are done with the reshaping from a higher dimension, with a lower dimension to higher dimension. Then let us also run this one and see if it will give us an output which we want. Print into nope. All right. Let us run this one and see. You see, it was a two-dimensional array, but because of us using the concept of flattening by specifying here a negative one, actually it has given us what? A one-dimensional array from a higher dimension to a lower what? To a lower dimension. That is what it means. All right. Let us go to our last concept here according to our script. Yes, according to our script here, from the second slide, we have so far talked about introduction to Numpy, installing and importing, Numpy array creation with n dimension, attributes indexing, slicing, reshaping, and flattening, and then we are going at the array broadcasting. You know, in Numpy, it has very, very many topics here, but I told you before that here I'm going to give you the basics. I'm giving you the basics like when a child is being breastfed, I give him just a minute to invite her to the place of eating food. Is that okay? And that is what I'm also trying to do for you here. Okay, what is NumPy broadcasting? NumPy broadcasting is actually helps you to perform mathematical operations on different arrays of different shapes or dimensions. Here we mean you can perform a mathematical operations on two arrays where one array is one dimension and another array is second dimension. Is that okay? Actually, I believe it's not the same in lists because lists we only have one dimension. So now you see the limitation why we don't use lists, because lists it limits a person in a way how he can express himself when he's analyzing data, especially numerical and numeric computing. Is that okay? Because now in this, when you have one dimension, when you're dealing with only one dimension data, now consider a scenario where you're working for a company and the data is two dimension or three dimension. If you only know this, then how will you be able to what? To tackle with other concepts. So we have said NumPy broadcasting refers to the performing mathematical operation on arrays of different what? Of different shapes. Here we say that an array with a smaller shape can be expanded to match the shape of a larger array. Don't worry, we are going to see it. Here I gave you an example We have an array 1, which is 1, 2, 3. We have our second array 2, which is 1, 2, 3. But this one is the second dimension array. Then we performed an operation on these two arrays. You can do it in your free time. It will give you an output. We are going to do this one here. We are going to do this one here. Yes, we get its sum, the sum of it. Then, all right. Let us do it. Let us do it. We have some good 5 minutes before we finish. We have some good 5 minutes before we finish. Let me remove this one. I want to use a simple example. This one is called array. I can call it array1 into empty dot array into, let me say 1, 2, 3. No, don't. I stop there. Then I create another array, which is second dimension. Let me say array2, and I give it empty dot array 1, 2. Oh, let me see. Then you can perform an operation. Let me say we want the sum. Let me say results is equal to array1 plus array2. If I print, no, because someone may say this is impossible. Let me tell you, in artificial intelligence, everything is possible. If at all you know how to manipulate everything and deal with everything around, yeah, it's very possible. Let us run it and see. Must give you an output, you see? You see an output? It's in 2 dimension, actually. We have got an array of 1 dimension and an array of second dimension, and they have performed an operation on them. Is that okay? As you can see here, the output. Let me try to zoom in my screen so that you can see very well. Let me zoom in my screen. All right. As you can see here, this is our output on what we have worked on so far. I believe I'm remaining with only 1 slide if I'm not mistaken. All right. So this is my last slide. Is broadcasting with scalars. Broadcasting with scalars, what do you mean by scalar? A scalar is just a single value. Yeah, so you can have 5 is a scalar value altogether. 9 is a scalar value. So you can perform an operation with an array and a scalar what? And a scalar value. Let us do the same here. I say result2 is equal to, let me say array1 plus your age, 20. Then I say print to result2. Why is it giving me an error? Oh, it is results, not result. Results2. Okay, let us run it and we see the output. It is 21, 22, and 23 altogether. That has got this 20 that's added on each what? On each element in our area 1. All right, ladies and gentlemen, that is our presentation of today. Allow me to leave you with some links where you can go and learn more of this. First link, if you are writing, though I didn't include them here, but the first link, if you are writing, you can write numpy.programmese. It is Z, no, not S. Yeah, that is where you can actually fully learn NumPy very easily, and it is very clear. Then you can try a guy called Bro Code on YouTube. He can also teach you this, and a guy called Giraffe on YouTube. There is a textbook on this, though I may not recommend it to you as of now because it is a bit complex here, and understanding it may need you to first grasp the concept of NumPy. Yeah, you can first try out those ones. They will help you very clearly. Otherwise, I wish you a nice day. I wish you a nice day. Thank you so much. Yes. Oh,